Hello children. In the previous video, we had covered the topic electric current. So it is suggested to watch that video first for better understanding. And as we'll be covering all the topics from NCERT, so please keep your book near you while watching the video. And you can find the link of the previous video in the description section as well. See, as we know that electric current is the rate of flow of electric charges. But here one question arises that what makes the electric charge to flow? Please underline this in your book. What makes the electric charge to flow? Answer to this question is potential difference. Please write the answer, potential difference, in your book. To understand this, let's consider a situation. Suppose we have two beakers filled with equal amount of water and they are both connected to each other by a pipe at the bottom. You can see. You'll see that water in both the beakers is as it is and there is no flow from any beaker to the other. If you are not allowed to change the amount of water in any of the beakers, so without changing the amount of water in the two beakers, can you make water flow from beaker 2 to beaker 1? See, answer is no, because they both are at the same horizontal level. But we can do one thing. We can raise the height at which the second beaker is kept. Now you can see once the second beaker is raised at a certain height, water can easily flow from beaker 2 to beaker 1. ठीक है, अगर हम beaker 2 को थोड़ा height पे रख देंगे तो water flow easy हो जाएगा. In the same way, electrons can move, charges can move only if there is a difference of electric pressure called potential difference. Please underline this in your book. And this difference of potential may be produced by a battery. Okay, may be produced by a battery consisting of one or more electric cells. The chemical action within the cell generates the potential difference across the terminals of the cell. So in order to maintain the current, please underline everything in the book. In order to maintain the current in a given electric circuit, the cell has to expand its chemical energy stored in it. तो होता क्या है कि इलेक्ट्रॉन्स तभी मूव करते हैं जब पोटेंशियल डिफरेंस होता है. और पोटेंशियल डिफरेंस कैसे प्रोड्यूस होता है? जब हम वायर को, कॉपर वायर व्हाटएवर वी आर टेकिंग, जो हमारा कंडक्टर है उसको हम बैटरी से कनेक्ट करते हैं. बैटरी से कनेक्ट करने से पोटेंशियल डिफरेंस जनरेट होता है. और बैटरी में क्या होता है? बैटरी में केमिकल्स होते हैं. तो बेसिकली यहाँ पे जो केमिकल एनर्जी है वो इलेक्ट्रिकल एनर्जी में कन्वर्ट हो रही है. Please open page number 202 of your book and let's read question number 1. Name a device that helps to maintain a potential difference across a conductor. So device that helps to maintain a potential difference. Answer is battery. Please write the answer. To understand the concept of electric potential and potential difference, let's consider another situation. Suppose we throw a ball in the vertically upward direction. To raise the ball to a certain height and to maintain the position of the ball above the earth's surface, some work needs to be done. Some work needs to be done against the gravitational field of the earth. ठीक है, अगर हम किसी बॉल को थ्रो कर रहे हैं अपवर्ड डायरेक्शन में, नीचे से ऊपर, और उसको उस पर्टिकुलर हाइट पे मेंटेन करने के लिए, उसकी पोजीशन को मेंटेन करने के लिए, बिकॉज अर्थ इज एक्सर्टिंग फोर्स इन डाउनवर्ड डायरेक्शन, राइट? To maintain the position of the object, some work needs to be done against the gravitational force of earth, as the earth has its gravitational field around it where its effect can be experienced, right? As earth has its gravitational field around it where its effect can be experienced, in the same way charge has a field around it where the effect of charge can be experienced. So this is the electric field. Electric word means charge, field, field of charge. So region or space around the charge where its effect can be experienced is called electric field. So you can see that here we have a source charge Q. So this is the region where its effect can be felt, right? So means if any charge would enter the field of this charge, it would experience either attraction or repulsion depending upon the nature of charge. So as we know that like charges repel and unlike charges attract each other. So you can see here that we have a source charge, it is positive charge, and when a target charge comes in the field of this, the given charge, it experiences repulsion. Consider a charge plus Q. See, this region represents the electric field of the given charge plus Q. Means if any charge would enter the field of the given charge, then that charge would experience either attractive or repulsive force that depends upon the nature of charge which is entering the field of given charge. So here we are considering a test charge Q naught. It is unit positive charge which is placed at infinite distance. See, the word infinite means it is not in the electric field of the given charge. इन्फिनिटी का मतलब होता है कि ये जो चार्ज Q naught है ये थोड़ा सा दूर है और ये इसके इलेक्ट्रिक फील्ड में नहीं है. Now let's move this charge Q naught towards plus Q. So as this charge Q naught enters the electric field of given charge, it will experience repulsive force exerted by plus Q charge. ठीक है, because both are positive charges. ये भी unit positive charge है और ये भी plus Q है. So this charge will experience repulsive force exerted by given charge. ठीक है, अब इस पे repulsive force exert हो रहा है in this direction by this charge plus Q. Now for this charge, see if this charge has to stay here, ठीक है, अपने उसको पोजीशन को मेंटेन करने के लिए और यहाँ पे रहने के लिए the charge Q naught has to do some work against the repulsive force. ठीक है ना, उसे कुछ वर्क करना पड़ेगा against the repulsive force. Here we have a question that what if we have a minus Q charge instead of plus Q charge? Then there won't be any problem because force is attractive this time. See, let's move the charge Q naught now, okay? Okay, again, see, this Q naught will experience attractive force this time. Now, again, the charge Q naught has to do some work against the attractive force of minus Q to maintain the position at a fixed distance. See, हमारा पर्पस ये है कि Q naught चार्ज को हम एक फिक्स डिस्टेंस पे रखें. तो अगर फोर्स अट्रैक्टिव होगा तब भी फिक्स डिस्टेंस पे नहीं रह सकता, अगर फोर्स रिपल्सिव होगा तब भी फिक्स डिस्टेंस पे नहीं रह सकता. For both the cases, Q naught has to do some work to maintain its position at this point. So the term electric potential at any point can be defined as work done in bringing a unit positive charge from infinity to that point. And it is a scalar quantity. Its SI unit is volt, which is denoted by capital V. Let's consider a charge Q. See, this region represents its electric field. And we have a charge Q naught here. It is a test charge Q naught, unit positive charge, which is placed at infinity. So when the charge Q naught is moved to point A, then electric potential at A can be defined as the work done in moving the test charge Q naught to point A. Okay. Similarly, when the charge Q naught is moved to point B, then electric potential at this point B can be defined as the work done in moving the test charge Q naught to point B. And when the charge Q naught is moved from A to B within the electric field of given charge Q, then we can measure the electric potential difference. Okay, we can measure the electric potential difference just by subtracting the electric potential at final position. Let electric potential at final position be VB from electric potential at initial position. Let's say electric potential at initial position be VA. So we can find the potential difference V by subtracting the electric potential at B minus electric potential at B, A. And this difference of electric potential is called potential difference, and which can be defined as the amount of work done. It can be defined as the amount of work done in moving a unit positive charge from one point to another in the electric field of given charge. Now, please underline the definition of electric potential difference in the book. See, we define electric potential difference between 2 points in an electric circuit carrying some current as the work done to move a unit charge from one point to the other. And mathematically, we can write potential difference between 2 points as the work done divided by charge. And here's the formula. Please enclose this formula in the box. It's V is equal to W by Q. Okay. And SI unit, as we had discussed, of electric potential difference is volts, and it is named after Alessandro Volta. Now open page number 202 and let's read question number 2. What is meant by saying that the potential difference between 2 points is 1 volt? So as we know that potential difference between 2 points is work done upon charge, right? So if W equals 1 joule and Q is 1 coulomb. So on putting these two values in the above relation, we'll get V as 1 joule upon 1 coulomb. It is 1 joule per coulombs. Now we know the unit of potential difference. It is volts. So 1 joule per coulomb is 1 volts. So from this, we can conclude that when 1 joule of work is done, to move a charge of 1 coulomb, when 1 joule of work is done to move a charge of 1 coulomb from one point to another, then potential difference is 1 volts. Now please underline the definition of 1 volt in the book. 1 volt is the potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to the other. Let's try example 12.2 now. How much work is done in moving a charge of 2 coulomb across 2 points having a potential difference 12 volts? So charge of 2 coulomb is given. Potential difference is 12 volts and we have to find the work done. So we know the relation between these three quantities as V equals W upon Q. Potential difference is work done divided by charge. So this implies W equals to V into Q. Now put the value of potential difference and charge in the relation. Potential difference is 12 volts. Charge is 2 coulombs. On putting these two values, we'll get work done as 24 joules. It's page number 202, and on the same page, you will find an in-text question. Yes, it is question number 3. How much energy is given? We have to find energy is given to each coulomb of charge. Each coulomb of charge means Q is 1 coulomb passing through a 6 volts battery. So potential difference is given, it is 6 volts. So we have to find energy. See, this energy is the electric potential energy, and electric potential energy at any point in an electric field is defined as the work done. So this is electric potential energy. Electric potential energy at any point is defined as the work done in bringing a test charge from infinity to that point. So as V equals W upon Q. So this implies W is equal to V into Q. Now put the values here. V is 6 volts. Q is 1 coulomb. So it is 6 joules. To measure the potential difference between 2 points, a device called voltmeter is used. Please underline this in your book, and voltmeter is always connected in parallel across the points between which the potential difference is to be measured. So potential difference is measured by an instrument called voltmeter, and it is always connected in parallel because components in parallel experience the same potential difference. That's all for today. In the next video, we'll be covering electrical components and their symbols.